Hello, and welcome to Astronomy Daily. I'm your host, Anna, and I'm really excited to bring you your daily dose of cosmic happenings. Today, we've got some really cool stuff to talk about, from a giant planet orbiting a tiny star to a weird star that might just solve one of astronomy's biggest mysteries. We will also cover China's reusable rocket and two galaxy clusters about to crash into each other again. So buckle up, space fans. It's going to be an awesome ride. First up, we're diving into the head-scratching discovery of a giant planet, TOI 6894b, orbiting a red dwarf star called TOI 6894. Now, this star is tiny. I mean, we're talking about 1/5 the size of our sun, which makes the discovery of this planet like a huge surprise. See, these small stars weren't thought to have enough material to even form giant planets. But there it is. TOI 6894b, a gas giant roughly the size of Saturn. It's kind of like finding a fully grown elephant living in a mouse hole, you know? This discovery kind of turns our understanding of planet formation on its head. The current theory suggests that the amount of material in the disk around a star, which eventually forms planets, is proportional to the star's mass. So a tiny star shouldn't have enough stuff to make a giant planet, but apparently, nature loves to throw curveballs. Now, because TOI 6894b has such deep transits, I mean, when it passes in front of its star, it blocks a whopping 17% of the light. It's a perfect candidate for atmosphere study. A team of astronomers has already applied for time with the James Webb Space Telescope, JWST, to do just that. They are hoping to find a lot of methane in the exoplanet's atmosphere. That'll give us a better idea of how this planet formed and maybe help us refine our planet formation theories. Pretty cool, huh? Next up, let's talk about a really odd star, Limos J 0804 plus 5740, residing in what's known as the Gaia Sausage. And no, it's not a galactic deli item. The Gaia Sausage is actually the remains of a dwarf galaxy that merged with our Milky Way billions of years ago. Now, this star, it may just help us solve one of astronomy's big mysteries. Where did the universe's heaviest elements come from? These elements, like uranium and thorium, are created through something called the R process. That's a rapid neutron capture process. Essentially, atomic nuclei rapidly grab neutrons in extreme environments, like neutron star mergers or supernovas, creating heavier elements. But here's the thing, we haven't quite figured out all the sources of the R process. And that's where Limos J 0804 plus 5740 comes in. This star is what they call an actinide boost star, meaning it has a high abundance of radioactive elements, actinides. So the star's unusual composition provides new clues about the different types of R process events that can occur in the universe. By studying it, astronomers hope to better understand where these heavy elements come from and how they're created. It's like piecing together a cosmic puzzle, you know? Okay, so shifting gears a little, let's head over to China, where a rocket startup called Space Epic, or CPOC, if you like it short, recently showed off its reusable rocket booster, the Yangtze-1. They had a test launch, and get this, it did a soft landing right in the ocean. I mean, sadly, it sank afterwards. But hey, the launch and the test were still a success. Apparently, the whole point was to test things like the engine's thrust control, shutdown, and restart capabilities. Plus, they tested free descent, gliding, and hovering before splashdown. Pretty cool, right? Now, this Yangtze booster is kind of interesting. It's made from lightweight, thin-walled aluminum stainless steel and runs on liquid oxygen and methane. It's about 4.2 meters in diameter and almost 27 meters tall. Now, I know what you're thinking. How does this stack up against SpaceX? Well, SpaceX's Falcon 9 booster is a bit narrower, but it's taller. And speaking of SpaceX, it's kind of wild how they've turned landing and reusing boosters into like a near daily thing. Meanwhile, China is catching up with a bunch of space startups popping up recently. And, you know, with China working on its own mega satellite constellation and planning some seriously ambitious missions, including their own version of the Hubble telescope, it's clear they are becoming a major player in space exploration. Space Epoch is hoping to reach orbit later this year. So, yeah, it's definitely going to be interesting to see what these China-based startups do in the coming years. All right, next up in our cosmic headlines, NASA's Chandra X-ray Observatory has spotted something pretty wild. We're talking about two galaxy clusters known as PSZ2G181.06 plus 48.47 that have already collided once and are now heading back for a second smash-up. Now, galaxy clusters, just so you know, are like the biggest structures in the universe, held together by gravity. They're basically massive collections of galaxies, superheated gas, and dark matter. These two clusters are about 2.8 billion light years away, and after their first collision, they created these huge parentheses-shaped shock fronts, kind of like sonic booms, but on a cosmic scale. These shock fronts are now separated by about 11 million light years, which is apparently the largest separation astronomers have ever seen. But get this, Chandra and XMM Newton data show that these clusters are now slowing down and turning around for another collision. Astronomers have spotted 3 new shock fronts that seem to be early signs of this second crash. What's really interesting is that the total mass of this system is less than other colliding galaxy clusters, making it a pretty unusual case. This event is giving scientists a peek into the dynamics of these massive structures and how they evolve over time. So that's your Astronomy Daily News summary for today, from a tiny star with a giant planet to colliding galaxy clusters. I've been your host, Anna, and I hope you enjoyed our little tour of the cosmos. For all the latest space and astronomy news, don't forget to visit our website at astronomydaily.io, where you can catch up on our constantly updating newsfeed. Until tomorrow, thanks for tuning in, and keep looking up.